Hi everyone, let us discuss this example. So in this example, we are going to find the value of surface integral of scalar field. So they have given a scalar field f of xyz, which is defined as y square, as well as they have given surface also. So we are going to solve this problem, but before that we will write the definition of surface integral of scalar field. Okay, so it is defined as double integration f over s is equal to double integration over d f of phi of uv. Here phi is a parameterization of a surface and it is defined on domain D. So that's why we solve this double integration over domain D. After that we have norm phi u cross phi v and then du dv. Okay, so this is definition of surface integral of scalar field. So what will I do? After that I will write the given information. So what we have, let me write. We have what is the function we have? F of xyz is equal to y square. Very simple function we have. So let us consider the surface also. What have they mentioned? S is a cylinder. Here S is a cylinder. Okay, I am simply writing in this way. X square plus y square is equal to 1. So you know that x square plus y square is equal to 1. It represents a circle in xy plane with center 0, 0 and radius 1. So let me draw a circle in xy plane. So we have a circle like this. Okay, it is three-dimensional figure. It is in xy plane. So that's why I am drawing like this. But see, it is a cylinder whose base is this surface, and as well as they have mentioned 0 less than or equal to z less than or equal to 1. That means that cylinder is bounded by z is equal to 0. Z is equal to 0 means what? Xy plane. And z is equal to 1. Z is equal to 1 is a plane, passes through z is equal to 1 and parallel to xy plane. That means we have a cylinder like this. You can easily see cylinder like this. And we have two planes. Z is equal to 0 and z is equal to 1. So obviously we will have the cylinder like this. Okay, I am drawing a rough sketch of it. So we have a cylinder like this. So this type of cylinder we have. So here you can easily see z is equal to 1 and here z is equal to 0. The equation of that cylinder is x square plus y square is equal to 1, radius is 1. What have they mentioned? It has and its top and bottom also. That means we have to consider the entire cylinder. See, that cylinder has three surfaces. The curved surface, the surface at bottom and the surface at top. So that surface S is made up of three different surfaces, bottom, top and curved surface. So we have to solve that double integration over all these three surfaces. So let me simply mention here S is made up of three surfaces as shown in figure. Okay, so I am showing that those three surfaces here. So here we have S1, I am calling it as S1, that curved surface. We will call it as S3 and at the bottom we have a surface, I am calling it as S2. So obviously, okay, just a minute, we have some space, let us use. See, then double integration f over s. Our target is to find a value of this double integration, but as we have seen, S is made up of three different surfaces. So I should write double integration over S1 plus double integration over S2 double integration over S3. So what we have to do, we have to solve the problem over surface S1 first, then over S2 and then over S3. And at the end we have to add all this, so then we will have the required answer. Okay, so let us start to work on surface S1. Okay, make a screenshot of it, then we will go further. So let us solve the integration over S1. Okay, so what is equation of S1? So equation of S1 is, as you can see here, S1 means a curved surface whose equation is x square plus y square is equal to 1. Okay, see, in previous videos we have already seen when we have cylinder, when we have paraboloid or when we have cone, we go for cylindrical coordinate system. I will do the same. So for that I am going to putting x is equal to y is equal to z is equal to. So the substitution is x is equal to r cos theta, y is equal to r sin theta and z is equal to z. But see that for curved surface, the radius is fixed. Radius is 1. So that means the value of r is 1. R is not varying here. R is a fix which is 1. So if I put r is equal to 1, we will have simply x is equal to cos theta, y is equal to sin theta, and z is equal to z. That means total we have three variables x, y, z, and we are converting them into two variables theta and z. So with the help of that, easily we can define a parameterization. Then parameterization of S1 is, the parameterization will be phi of theta and z. Since with the help of theta and z, we are defining the surface. X, what is our x? Cos theta. Y, what is our y? Sin theta. And the third component is z. So obviously we should write the limits also. Theta, I am going to write the limits of theta. So as you can see here, we have to cover a complete surface, getting that? So we should move that theta by 360 degree, then we can easily cover the entire surface. So theta should vary from 0 to 2 pi. So let us talk about z. They have clearly mentioned at bottom, at z is equal to 0, that surface starts, and at z is equal to 1, we should go. So z should vary from 0 to 1. So in this way we got the limit. Since we have to cover a complete surface, so we should rotate it by 360 degree. So that's why theta should vary from 0 to 2 pi, and it has height 0 to 1. So that's why I am writing in this way. So after having a parameterization, we should do some basic calculation. That is, we have to find derivative of phi with respect to theta, with respect to z, their cross product, their norm. Okay, all these things we are going to find now. So then phi theta, derivative of phi with respect to theta. Derivative of cos theta is minus sin theta. Derivative of sin theta is cos theta. And derivative of z with respect to theta is 0. Since we are differentiating with respect to theta, so that's why z is constant. Now derivative of phi with respect to z. Its derivative with respect to z is 0, since z is not there, theta is there, getting? And when you differentiate with respect to z, it will be constant and derivative will be 0. Same thing will happen here, derivative 0 and derivative of z is 1. So we got partial derivatives. Let us take cross product now. Okay, just a minute. So I will do the further calculation here. So then phi theta cross phi z. So you know well, to find the value of cross product, we should solve a determinant whose first row is obviously I, j, k. The second row will be phi theta we have. No? So I should write these values here, minus sin theta, cos theta and 0. So coordinates of that phi z 0, 0, 1. So I should write here 0, 0, 1. Right. So you know well how to find the value of determinant. I should write I first. Product of these two, cos theta, and product of these two, 0, minus j. So when we solve determinant, when we take the middle value, always we write a minus sign there. Minus sin theta into 1, we will have minus sin theta, and 0 into 0, 0, plus k, 0 minus 0. So obviously 0. So this is equal to cos theta minus minus plus sin theta and 0. So we are interested to find its norm. So let us find norm phi theta cross phi z. So this is equal to, so you know well how to find the value of norm. Square root of square of first cos square theta, square of second sin square theta, square of 0, 0. Cos square plus sin square 1 and square root of 1 is 1. So as well as we want one more thing, that is f of phi of theta z. Now f of phi of theta z. So let me put the value of phi here. What is the value of phi? It is, yes, here, cos theta sin theta z. Cos theta sin theta z. So this is equal to, so definition of f, where is definition of f? I have written here. Definition of f says y square. Y square means what? Whatever the second coordinate we have to take it square. So here the second coordinate is sin theta, so its square will be sin square theta. That's it. So everything is ready now. Let us put all these things in the definition to find the value of surface integral. Then double integration f over s1. We are solving the surface integral over surface s1. Okay, only over this s1. Let us solve it. This is equal to double integration. The definition says over d f of phi theta z. Okay, I don't have enough space, so I am writing in this way. Norm phi theta cross phi z. Okay, where shall I write? I will write here. We don't have enough space to write. Just a minute, it is not properly visible here. So I am writing the same thing on the next line. So this is equal to double integration f of phi of theta z norm phi theta cross phi z d theta dz. Obviously, I should write the limits of theta and z. Limits of theta 0 to 2 pi, right? 0 to 2 pi. And limits of z 0 to 1. So f of phi of theta z, we have already calculated its value is sine square theta and the value of norm is 1. So let us put all those values there. Make a screenshot of it first, then I will go further. Okay, so this is equal to integration 0 to 2 pi integration 0 to 1. Okay, so its value is sine square theta. Okay, value of norm is 1 and dz d theta. So first of all, we are integrating with respect to z. So sine square theta is constant, will come outside. So this is equal to integration 0 to 2 pi. Sine square theta will come outside. Integration of dz is z, limits 0 to 1, right? This is equal to integration 0 to 2 pi. I am putting the upper limit. So 1 minus 0, 1. Okay, so if you have 1, no need to write anything. Simply I will mention here sine square theta. Actually, we cannot find its integration directly. So we need to take a help of trigonometry's formula. Okay, so that formula is I am going to use here 0 to 2 pi. Sine square theta means 1 minus cos 2 theta divided by 2 d theta. So basically 1 by 2 is a constant, will come outside the integration. So that 1 by 2 will come outside. Integration of 1, which is theta, minus integration of cos theta is sin theta. But see, cos 2 theta is there. So sin 2 theta divided by 2, 0 to 2 pi. So 1 by 2, I am putting upper limit 2 pi here. I am putting 2 pi here. So sin 4 pi. But we know that sin n pi, let me write somewhere, sin n pi is always 0, sin n pi, getting n means any natural number, getting or positive integer or negative integer also you can take. So sin n pi is always 0. So sin 4 pi is 0, so its value will be 0. If I put 0, 0, sin 0 is also 0. So what will happen, that 2 will get cancelled and we will have the value pi. It means the surface integral, okay, of scalar field f over surface S1 is pi. So the one task is finished, first task is finished. Now we have to consider a surface S2, then we will go for S3. Make a screenshot of it first, then I will go further. So let us talk about S2 now. Okay, so the equation of S2, as you can see here, S2 is the bottom of that cylinder whose equation is Z is equal to 0, then that circle lies in, that bottom of that cylinder lies in xy plane. So its equation is Z is equal to 0, but that S2 is bounded by a circle with center 0, 0 and radius 1. I have written here. Okay, so let us find its parameterization. So we have a circle, so obviously I will go for polar coordinate system. Okay, so for that I am going to putting x is equal to r cos theta, y is equal to r sin theta, and z is equal to, see here z is equal to 0, they are already given. Since S2 is a surface which lies in xy plane whose equation is z is equal to 0. So here we have expressed x and y in terms of r and theta. As you can see here, we have a circle with radius 1. So that's why r will vary from 0 to 1. So here let me write parameterization of S2 is phi of r and theta. So with the help of r and theta, I am going to express x, y, z. Okay, so phi of r theta, x is r cos theta, y is r sin theta, and our z is 0. So let us talk about limits now. We have a circle here with radius 1, so r will vary from 0 to 1. And we have to rotate, okay, that radius by 360 degree to cover a complete circle. So that's why theta should vary from 0 to 2 pi. So in this way we got a parameterization. So let us do some basic calculation. That means derivative of phi with respect to r, with respect to theta, their cross product, their norm. So let us find all these things one by one. So derivative of phi with respect to r. So derivative of r is 1, cos theta is constant. Derivative of r is 1, sin theta. And 0, derivative of 0 is 0 obviously, phi theta. Derivative of this one with respect to theta, r is constant, derivative of cos theta is minus sin theta. R is constant, derivative of sin theta is cos theta, and derivative of 0 is 0. After that we have to find their cross product. Let us find it. Okay, just a minute. We have some space, let us use. Okay. So then phi r cross phi theta. So cross product we have, that means we have to find its value by solving a determinant. The first row is obviously I, j, k. The second row, that means that components of phi are cos theta, sin theta 0. Cos theta, sin theta 0. And phi theta, which is minus r sin theta, let me write here, minus r sin theta, and r cos theta and 0. So you know well how to find the value of determinant. Okay, product of these two 0 obviously, and product of these two 0. So obviously 0 minus j. So for the middle term we always write a minus sign when we solve 3 by 3 determinant. Okay, so j, product of these two 0 minus product of these two 0, plus k, product of these two r cos square theta, minus product of these two minus plus r sin square theta. See, the first one is 0 component, second component is also 0. For third component we can take r common. If you take r common, in bracket we will have cos square plus sin square, which is 1. So that means only r will be there. Getting by taking r common, cos square plus sin square will be 1. So only r is left there. So let us find norm now, phi r cross phi theta. So you know well how to find the value of norm. It is square root of first 0, square of second 0, square of third, which is r square. So square root of r square. So square and square root will get cancelled to each other and we will have r. So last point now, then f of phi of r theta. Okay, since for find the value of surface integral of a scalar field, in the definition all these things are required, so we are finding their values one by one. So the last point is f of phi of r theta. So f of, what is our phi of r theta? What is it? Yes, r cos theta, r sin theta and 0. So what is definition of f says? The square of the middle component. Here the middle component is y, we have to take it square. So here the middle component is r sin theta, so I should take it square. So it will be r square sin square theta. Then double integration f over S2. So now we are finding the value of surface integral of f, scalar field f over surface S2. So let me write a definition, double integration f of phi of r theta. Okay, norm phi r cross phi theta and dr d theta. So what will be the limits here? Limits of r 0 to 1 and limits of theta 0 to 2 pi. See, f of phi of r theta already we have calculated, its value is r square sin square theta and the value of norm is r. So all these values I am going to put it here. Okay, just make a screenshot of it, then I will go further. So let us simplify it. So this is equal to integration 0 to 2 pi 0 to 1, right? So value of this f of phi of r theta is r square sin square theta, right? Value of norm is r and dr d theta. So first of all we will integrate with respect to r. So sin square theta is constant, will come outside. So sin square theta will come outside. So r square into r cube. What is integration of r cube? R raised to 4 by 4. So let me write here directly. So r raised to 4 by 4, 0 to 1 d theta. So that 1 by 4 is a constant, getting it will come outside. So 1 by 4 I am taking outside, 0 to 2 pi sine square theta. See, if I put 1 raised to 4, 1 and 0 raised to 4, 0 d theta. So 1 minus 0 is obviously 1. So only sine square theta is left there. But see, we cannot integrate sine square theta directly. So for that, we need to take a help of trigonometric formulae. So sine square theta is 1 minus cos 2 theta by 2. Getting for S1 also, I think we use the same formula. So let me write here 1 by 4, 0 to 2 pi, 1 minus cos 2 theta by 2 d theta. So that 1 by 2 is also constant, will come outside. Getting? So 2 into 4, 1 by 8. So let us integrate remaining part. So 1 by 2 we have taken outside. So integration of 1 is theta, integration of cos is sine. But 2 theta is there, so its integration will be sine 2 theta divided by whatever the multiple of theta we write in denominator. So it will be 2, 0 to 2 pi. So let us put upper limit, lower limit, 1 by 8. I am putting 2 pi here, 2 pi. If I put 2 pi here, we will have sine 4 pi. Sine n pi is always 0, so that's why sine 4 pi is 0. If I put 0, 0 and if I put 0 here, sine 0 is also 0, so 0. So only 2 pi is there, getting? So what will happen, that 2 will get cancelled. So here simply we will have pi by 4. So double integration of f over surface S2 is pi by 4, getting? So make a screenshot of it, then we will go for surface S3. So now let us talk about S3, getting? So equation of S3 is Z is equal to 1. So S3 is the top of that cylinder, getting? Which lies in a plane Z is equal to 1. So its equation is Z is equal to 1, but it is bounded by a circle with center 0, 0 and radius 1. Okay, so this type of cylinder we have, so it is bounded by this circle. So after that, what will I do? I will find the parameterization. Okay, so for that I am going to putting x is equal to y is equal to z is equal to. So when we have cylinder, we go for a cylindrical coordinate system. So it will be x is equal to r cos theta, y is equal to r sin theta, right? R sin theta. And see here z is fixed, whose equation is 1. So that's why value is 1. So that's why z is equal to 1, right? So its parameterization will be then parameterization of S3 is phi of r theta. Okay, so first we write value of x, which is r cos theta. Next value of phi, which is r sin theta, and z is fixed, so its value is 1. So I am writing in this way. Let us talk about limits. So we have a circle at height z is equal to 1. So to cover a circle, okay, its radius is 1. So that's why r obviously varies from 0 to 1. Okay, and to cover a complete circle, that theta should be rotated by 360 degree to cover the complete circle. So that's why theta should vary from 0 to 2 pi. So these are the limits of r and theta. So this is a parameterization. So after getting parameterization, what we do? We find its derivative with respect to r. We find its derivative with respect to theta. We find the cross product. We find the norm. And at the end, we find f of phi of r theta. So the same steps we have to do here. Getting already for S2 we have done. So same procedure we have to do for this surface S3 also. Okay, I am leaving it is an exercise for you. I am directly telling you the answer. So by solving the problem, so let me give a short hint for you. So double integration f over s. The definition says f of phi of r theta, norm phi r cross phi theta, dr d theta, limits of r 0 to 1, limits of theta 0 to 2 pi. So what you have to do? You have to find derivative of phi with respect to r first, derivative of phi with respect to theta, their cross product. After that, you have to find the value of norm, and at the end f of phi of r theta. So by putting all those values here and by solving the double integration, you will have the answer pi by 4. Getting? So the same things we have already done for surface S2. So I hope you can complete it for S3 also. So I am directly writing the value pi by 4. So at the end, you remember Okay, let me write here. So our target, okay, what is our task? To find a value of f over surface S. S means a complete cylinder including its top and bottom. So as I told you, S is made up of three different surfaces over S1, S2 and S3. So double integration of f over S is equal to double integration over S1 over S2 and over S3. So all things are done now. So double integration over S1 we got its value pi, over S2 we got its value pi by 4, and for S3 also we got its value pi by 4. So let us simply add. So pi by 4 plus pi by 4, pi by 2. So if you cross multiply 2 pi plus pi by 2, so it is 3 pi by 2. So this is required answer. Okay. So problem is over. Make a screenshot of it, then we will stop. Thank you. See you.